Adrian, let's move to HACARUS. You're going to talk about using AI and hyperspectral image analysis to speed up inspection by 600%. Wow, looking forward to it.
Thank you. So the first and most important thing, if you find anything I say interesting or you'd like to learn more, please send an email, adrian@hacarus.com. This is true for the people in the audience and anyone looking online or looking at the stream later. So, if you can only remember one thing, remember that HACARUS is the company that specializes in providing highly accurate results from small data. To give you a brief introduction of who we are, HACARUS is a Japanese startup founded in Kyoto. We have done around 100 projects today in mainly two verticals, visual inspections as well as in predictive maintenance. Most of our customers are still in Japan, but we're now making the stride into the European market. So what you can see HACARUS as a digital transformation partner. And what we really focus on are two things. We focus on automation and focus on digitization. Within the Japanese market, the idea of digital transformation is quite new and quite popular. And today I would like to focus on a use case of a project we did for digital transformation. So, before we get into the use case, just a few seconds or a few moments about the core technology that powers HACARUS AI engine. What we are working with is something called sparse modeling. Sparse modeling is a different approach compared to deep learning. We don't have a neural network or something like that. Rather, we assume that there is a certain degree of sparsity that can explain results. And what sparse modeling has as a power is it allows us to have explainability by design. We can show the decision-making process that our model takes, and we can also give you the sparse code. It's incredibly energy efficient and sustainable. We do not need any GPUs or do any training on a supercomputer. We work with very small data sets, so it's a frugal approach. We can get highly accurate models from as little as 20 samples. Now, we didn't invent sparse modeling. It originally comes from the space of medical imaging, and you may be familiar with its use to create the first ever image of a black hole, which came in 2017. So, I'm not going to talk more about technology. Now I'm just going to talk about how we help our customers save time and money. Because we think that technology is an enabler for value generation. It doesn't matter how advanced your stuff is if it doesn't solve a customer problem. So the customer problem we're going to look at today is together with a company called the DKS. DKS is quite typical of a Kyoto company. It's a chemical specialist. It's more than 100 years old, and they're expert in their field of creating various chemical materials. I think it's quite similar to what's in Germany, the Mittelstand. I believe this is somewhat similar. So old companies that are specialized and are market leaders in what they do. Now, they had a problem where their inspections were based on tacit knowledge. They had inspectors that were sitting and doing quality control, just feeling the moistness of a specific chemical material with their hands. And this means that you have inconsistency between inspectors. You have old inspectors that are retiring and their knowledge disappears. So you have a big problem with scalability and bringing this forward. So what we did is we came in and we combined both on the hardware side a hyperspectral imaging camera, HSI camera, as well as an AI model that's able to detect within these images the level of moistness, the correctness. Really what we're detecting is the intersect between the darkness and the lightness and what is the ideal environment. But what that means is we get inspection results that are quantifiable and replicable. So they can get the same results every time and they can scale it. The results of this is a 600% increase in the speed. We're going from spending up to 20 minutes for inspections down to mere minutes. And this leads to an expected saving of 50% over the next 2 to 3 years in training inspectors to do this by hand. And most importantly, freeing up the inspectors to do more meaningful work to make the product better. So this is also going to enable them to increase the volume and the throughput. And this material actually ends up in lithium batteries, which is a very growing business now in the EVs. If you're interested in learning more about this specific case study, we have an article in the InVision magazine for this month. So if you go to this link, you'll be able to read in-depth where we cover the technology behind it. So my team are now ready to go into the European market. We're doing quite well in Japan, and we're now ready to take the plunge and come here to Europe. I'm really looking forward to meeting customers, inviting some of you over to our booth. We're right here. JJ's waving his hands, so he'll be happy to have a conversation with you about how we can help you solve. So, in summary, market-proven, made-in-Japan solutions ready for global clients. We provide sustainable, highly accurate solutions that work with small data sets. My special offer for anyone here at Vision or anyone watching online is we can do a free feasibility study. This means you give us some sample data, we create an initial model for you, and we discuss how to proceed from there. But we're willing to do some free pilots here, do some free feasibility studies for customers that are coming from Vision. And that's my presentation. Thank you.
Thank you, Adrian.
Okay.
Questions?
Unfortunately, my heart didn't translate as well, but that's the way it is.
So, what's the recognition rate you get with this?
So we're
deep learning-based system.
Yeah, so sparse modeling is the core technology behind it, and today I've focused on the HSI use case because I think that's something new, that's not something coming. But much like some of the other presenters, we also do quality controls for automotive industry, tier 1 components, semiconductors, etc. So the accuracy is going to depend a little bit on the use case. We have situations where we are in the high 90s, but we also have situations where we're just trying to be better than the human inspectors that are doing it. So if you look at this specific use case, we're not talking about high 90s. We're talking about going from, I don't know, 80s to 90s or something like that. But it really depends on where we're starting, how accurate we are. But there's no reason for this not to be as accurate as deep learning. And if you want to get into the nitty-gritty, I'm happy to send some white papers. We use something called the dictionary learning, where we basically create a feature dictionary of all the good features. So it's learning only with good samples, supervised learning. And when we're presented with something new, we detect that anomaly. But again, I have white papers. I'll be happy to send them to you. And in a short answer, it's as accurate.
Could be as accurate.
Could be. Absolutely. Not always. I'm definitely not promising 100% here.
I could allow another question. Is there one? No? Adrian, thank you.
Thank you so much.
Perfect.